Good morning. Good morning. Great, thank you. Welcome to Dartmouth College. I am Maria Lascaris. I'm Dean of Admissions and Financial Aid, and it is a real pleasure to welcome you to campus today for our second in our Faculty Friday series this summer. We're really thrilled you're able to join us. We've got a power-packed schedule today with a lot of events to introduce you to our community here at Dartmouth. And we're kicking it off this morning with a really special treat, the opportunity to hear from a Dartmouth faculty member. There are obviously many reasons why students choose Dartmouth and why students and alums feel so passionately about their experience here. But I think my guess is if you were to survey the alums and our current students, faculty would rank really high on the list of why they feel this institution is such an incredible place to spend 4 years. So without further ado, I'd like to introduce you to our speaker this morning. We are fortunate to be joined by Marcelo Gleiser, a member of the Dartmouth faculty since 1991. Marcelo is a theoretical physicist who specializes in cosmology, nonlinear physics, and astrobiology. I went to take a look at the courses that he teaches, because I always think it's fascinating to look at the courses that faculty teach. And so a little bit about Marcelo's teaching. He teaches courses at all levels, from advanced graduate courses in quantum field theory and cosmology, as well as introductory physics classes, so what you'd expect from a physics professor. But he also teaches a very popular Physics for Poets class. So all those liberal arts students out there who don't want to do physics, we've got a special course for you, Physics for Poets, that presents physics and astronomy as part of an evolving cultural process as a search for deeper understanding of who we are and the world around us. He also teaches a course in comparative literature from time to time that's called Us and Them, Aliens in Fiction and Nonfiction. The thesis of the course, or the point of the course, is really to examine how our conception of extraterrestrial life has changed science, and as science advances, how we learn more about the cosmos and ourselves, our conception of what extraterrestrial life is. In addition, how aliens are mirrors we use to understand who we are, what our fears, what our strengths, and what our weaknesses are. So really fascinating courses that you could take if you were a student here at Dartmouth College with Professor Gleiser. A couple other things. Marcelo is also a fellow of the American Physical Society and a recipient of the Presidential Faculty Fellows Award from the White House and the National Science Foundation. He's also very active in the public understanding of science, having authored 3 books and dozens of essays in magazines and newspapers around the world. He's also the co-founder and a regular contributor to a blog on science and culture hosted by National Public Radio called 13.7. So without further ado, please join me in welcoming Professor Marcelo Gleiser.
Hi, everyone. Thanks for coming and listening to a lecture by a professor, really. And then there will be a quiz for the prospective students afterwards, see if you really measure up or not. Just kidding. Also, I would like to apologize in the name of the administration for the bad weather that we procured for you today. It's a real shame. It shows you that New Hampshire is not all about live, freeze, and die. There is also a little bit of sunshine and warmth in the summer. Okay, so in the short time that I have here with you, I wanted to give a little sample of why it's worthwhile to come here to study, and also something that I do, a little bit of what I do as a professor and also as what I would think, a public intellectual trying to bring science to the general public. So not just inside the classroom, but also outside the classroom. So we have here a picture in the blackboard. Well, it's not a blackboard, actually. It's a wonderful, huge screen, but we're used to blackboards and things like that. That tells you the history of the universe, right? So basically, we now can make a picture like this that tells you that the universe is about 13.7 billion years old. So we know the universe, just like us, had a birthday. It was a Thursday, about 13.7 billion years ago. And it's been expanding and changing ever since. So we have a very dynamic picture of what our universe is like in terms of what is it made of and how stars are formed and how come people can exist in this universe, right? And I'm going to try to give you a little bit of an idea of what this is about in a second. But what's really interesting is to not present just the science of astronomy and physics, etc., but how science is part of a much broader cultural context where it is asking questions which happen to be much older than science itself. So when you're asking a question about where do we come from, you know, where did the world come from, how come there is something rather than nothing, these are questions that have been with us for thousands and thousands of years. So there is a place for science, which is a very pragmatic place where, you know, we try to build a very fast microchip so our next generation iPhone will be even faster or something like that. But there is another place for science where it engages with some very basic cultural questions that have been with us for a very, very long time. And I like to talk about science within that broader context, at least here today. So Maria was talking about this Physics for Poets class that I teach often, and it's really called Physics 1, Understanding the Universe. And basically, it does tell you the history of physics all the way from the pre-Socratic, the Greek philosophers of ancient Greece, to the modern time, to cutting edge, to black holes, Big Bang, the Higgs boson, all those things. So it's interesting then to have this sort of more broader context for science because it justifies also, you know, what is the value of a Dartmouth education. And I'm here to tell you a little bit about that. So being human and expanding universe has something to do with us being here in this auditorium today at Dartmouth. So let me start from the beginning, right? So what we want when we teach our students here, okay, we want to prepare thinkers for the world at large. It's not just a person that is going to be have a very specific knowledge about a question, which will also come when you have your major, but people that can actually think about broad questions in broad ways. And so we do that because we know, everybody knows, the world is changing very fast. There are very fundamental conflicts out there. There are very fundamental problems that we have. For example, the issue of energy and the issue of water distribution in the world and endemic diseases. And these are questions where different kinds of thinking must work together in order to produce solutions, right? So you can't just focus on very specific topics. We need to have people that are able to kind of grasp a variety of points of view in order to construct solutions that are actually viable, that can actually make sense, right? And so in that sense, we want to explore these multicultural aspects of knowledge, not just a single aspect of knowledge. And the value of a liberal arts education. For example, I grew up in Brazil. I actually am from Rio. Let's not talk about the World Cup, please. That is something I want to forget forever. It didn't really happen. It was an illusion. It was actually a computer simulation done by Germans, you know. It's not really a game. We were fooled to believe it was a game. But leaving that aside, why liberal arts? I didn't have the privilege, really, of a liberal arts education in the sense that, you know, when you go to university in Brazil, you choose your major right from the beginning, and you only have courses on that topic, period. So it's not like here that if you're going to become a physics major or political science or government major, you're going to take courses in philosophy, you can take courses in drawing, in cinema history, and all sorts of different aspects. And that is the idea that will give you some sort of foundation to be able to think broadly about different questions as opposed to just specifically, right? And I'm a big defender of this ability of cross-disciplinary thinking. That's why I come up with these courses that combine the sciences and the humanities fairly often. For example, last spring, I don't think Maria even knows that, but last spring I came up with a new course, which is called Question Reality, ! Right? And it's, again, for science and non-science majors. It's a small seminar style class that is only about 15 students in the classroom. And it's not even like a classroom. It's a long discussion table. And I present ideas, the students do the readings, and we jointly become a community of intellectuals talking about questions. So the question in this course in particular was, how do you know that the world is real? You know, how do you know what is reality? You know, we have this perception coming from our five senses. You know, you can see me, you can hear me, and you say, yep, that's it, that's reality. Well, not quite. That's only a very small part of reality. There is a whole invisible world out there. You have, for example, all the FM and AM stations are transmitting radio waves across this auditorium right now, and they're here. We don't see them, but they're very present, so much so that if you turn a radio on, you can hear music, right? Of course, the sound of that radio has nothing to do with the electromagnetic waves, but the waves are there in order to do that. Neutrinos, these invisible particles coming from the sun, you are being attacked by neutrinos right now. About 1 trillion. 1 trillion is a 1 with 12 zeros afterwards of them are hitting you per second. And we have no clue this is happening, right? Because neutrinos are also known as the ghost particles. They go through, they hardly interact with anything. But these things are happening, and if you don't have instruments to amplify your worldview, you would never know. Right? So in a sense, science is this reality amplifier that can show you things that you would not know otherwise, right? And you need that to understand not just the fundamental ideas that we come up with, you know, as thinkers, philosophers, social scientists, but also the nature of physical reality. So if you're going to be a philosophy major, you should also know about the foundations of physics and mathematics, etc. Right? Hence the idea here. And of course, you know, the buzzword in cutting-edge education is to create the ability to think critically about what's going on. So we are all bombarded with information all the time. You know, it's through the internet and op-eds and newspapers. How do you decide your position with respect to somebody's idea or point of view, right? You have to be able to think critically, reflect, combine different kinds of knowledge in order to have an opinion, right? And to affect some difference in the world at large. And so that is something that we are very much focused on here, you know, trying to create a community of thinkers that actually are able to come up with arguments for themselves so that they can have their own personal intellectual freedom and have a sense of empowerment, right, through education. And how do we do it? Well, you know, basically here at Dartmouth, we have this idea of the teacher-scholar, right? So what's the teacher-scholar? Well, the teacher-scholar is like, we are not just teachers, right? I would say that 95% of the faculty here at Dartmouth, we are also engaged in academic research. We are intellectuals that are producing knowledge in academia. So in my case, I have a research group where we write papers, we publish in journals, we go to conferences, we engage in the world at large, you know, and have a very good place in, at least in my case, in cosmology and particle physics in the community of physicists in the world. And my colleagues in the brain sciences or in the biology department, they all do that. So in the humanities, social science. So it's the notion that in order to be an effective teacher, you should also be engaged with the cutting-edge ideas of your field so you can bring this new stuff to the classroom so the students are learning not from the old books, but from what's happening at the forefront of knowledge as well, right? So that's a very, very important point. And of course, we actually do teach our classes here. So I'm not going to send my TA to teach my class. I'm actually going to be teaching them myself. Watch it, because that's not true in most of the cases out there. The other one is, as I just said, you know, our faculty, of course, is top-notch. You know, we're all known in our fields in the world. And very importantly, we try to engage our students in research right from the start. So there is something called the WISP project, for example, called the Women in Science project, which is targeted for first-year female students that want to engage in science, right? And so they are paired with professors from different departments, and right from the get-go, you can start doing research in a lab, for example, right? And this is something that is continued all through the 4 years in different levels of engagement, right? And the curriculum, of course, Maria already mentioned, so I'm going to skip. So in practice, how do you do this? Well, you know, instead of the showing, you know, let me not tell you how we do this, but let me show you a little bit, you know. So in the last few minutes that we have, let me tell you how we do this. Okay, so let me start with a quote from a French philosopher from the 17th century, okay, who is a brilliant guy called Bernard Le Bovier de Fontenelle. So he wrote this book in 1686, which is a book called A Dialogue on the Existence of Other Worlds, okay, or something to that extent, where he wants to know if there is life in other planets. So it does come from that course, Us and Them. So this is the same year, for those of you who studied physics in the high school, this is the same year that Newton published his book, Principia, which is where the laws of physics, the laws of motion, and the law of universal gravity came about, right? So that's the same year. And he says something which I think is absolutely brilliant. You know, he says that all philosophy, and what he meant by philosophy here was the search for knowledge in general, okay? Not just philosophical knowledge, but scientific knowledge, is based on two things only: curiosity and poor eyesight, right? Why that? Well, because we want to know, right? We want to know as much as we can all the time. However, we are limited beings. We can't know everything. So a lot of the tension in the history of knowledge is precisely between trying to know so much and not being able to answer all our questions, right? And that's the short-sightedness that he's talking about. So what do? We try to amplify our vision, right? So our instruments, for example, are one way in which we can do that. Just think of the history of science and knowledge in general before and after the microscope, right? Before the microscope, we had no idea where diseases would come from, you know, at least from a microscopic perspective, right? So suddenly, you know, you look at a drop of water and you realize that there is a whole world out there that you could not even see with your eyes, but it's as real as it can be, but we can see that now because you have a new instrument. So this idea that new instruments can change worldviews is very much the case, right? And if you go through the whole history of knowledge, you see this happening on and on again. The telescope, of course, is another example. Penicillin is another example. And there are all sorts of examples in different areas of knowledge where different instruments led to the discovery of either new cures for diseases or new ways of picturing the universe that were unprecedented, that we could not even have considered before, right? So when we look at that and these questions that we've been asking, right, we realize that the questions that I'm interested in, at least, you know, are questions which are very old, right? They belong to the origins of thought. And in fact, I put this slide here to show the diversity of religious experience and how different religions have thought about questions of origins, for example, right? And it's really amazing that if you look in different cultures, right, you have different creation myths, you have different stories of creation from different parts of the world, all trying to make sense of the same question: where did the world come from, right? And of course, here in the West, we're very familiar with the biblical narrative, right? The Genesis, and God says, let there be light, etc. But there are different stories out there, right? And they all have something to say. They're all very particular to the place where they were developed, right? But they're all trying to engage in the same kind of question. And now you fast forward thousands of years to today, right? And now we have cosmologists, which are, cosmology, by the way, is the study of the universe as a whole, right? We want to understand. It's not a very humble place for, you know, humble way of, part of science. It's like the big question, you know, where the universe came from and how does it evolve, etc. But what is the most complicated question we can ask there? The origin of the universe. So in a sense, we are engaged with the same kind of questioning, this sort of urge to know our origins as our ancestors have been. So there is a continuity, a cultural continuity between their questioning and our questioning. The difference, of course, is in the methods, right? The methodology of science is very different from the methodology of religious discussions, but the questioning is very much the same. And in fact, as you go on questioning nature, right, you realize that our views of the world change. So for example, when Columbus got here, right, so 1492, what was the universe that he lived in? Completely different from actually the universe that Newton, just about 200 years afterwards, was living, and certainly very different from our universe today. So for Columbus, right, so for Columbus you had a universe that the Earth was at the center of everything, the center of creation. It didn't move, and it was surrounded by spheres, like an onion. Like this looks like a chopped, you cut an onion through the middle, like that. And each one of these layers was an invisible crystal sphere made of because you could see through to see stars. And each one of these things would revolve and take the planets around, right? And at the periphery, at the outside, you had the sphere of the stars. And of course, out of there, you had really the realm of God, right? So Columbus, of course, would be part of the medieval Christian theology where God would be on the outside of the universe. And in the center, at the very center of the earth, was hell, right? So you had the devil much closer to people here on the surface than God all the way out there. So you had to really struggle to ascend into the realm of grace, right? And that's why medieval cathedrals have this very vertical architecture, right? Because as you go in, you're forced to kind of look up, right? So that you connect to this ascension, this notion that you can go up into the realm of grace of God. So that was the view that existed in the 1500s, so to speak. But then comes Copernicus, right, 1543, publishes his book where he says, no, it's the sun that is the center. The earth is just a planet. So that generated a major upheaval because it messes up with the whole conception of this vertical ascension from the earth to heaven. And then people start to ask all sorts of theological questions. But one of them is one that became very persistent, which is if the earth is not the center, it's just another planet, right? Then what is the place for humanity in the cosmos, right? I mean, why do we matter, right? In fact, people would say against science, they would say, these scientists are terrible because the more they understand about the universe, the less important we become, right? And that's just not cool, right? I mean, first, we were at the center, and now we're not the center, we're just a little planet. And then we move on to the modern theory. The sun, of course, our sun, is just a star. In our galaxy, there are about 200 billion suns, right? And the sun is not even a very big star. And our galaxy is just one amongst hundreds of billions of other galaxies. So we're becoming smaller and smaller and smaller, right? Kind of hiding behind here, really. And then, to top the indignity, we found out that if you look at what the universe is made of, right, and you look at the composition, like what is the recipe for the universe, it turns out that the matter that we are made of, we and stars, protons, electrons, that stuff is only 5% of the whole thing. 5%. So what's the rest? It's stuff we don't know, called dark energy, dark matter. And in my department, in my group, we looked at what is the nature of this dark energy and dark matter. And I think we have a few minutes for questions afterwards. So if you want to ask, what is that? I'll be happy to explain, but I will press on. But the point here is that we are only made of 5% of the stuff of the universe. We're around a star that doesn't really matter. We're around a galaxy that doesn't really matter. So why do we matter, right? So can science kind of somehow bring back the sense of importance that humanity seems to have lost as we learn more and more about the universe, right? So this is what I'm talking about, right? So this is one of the most spectacular pictures ever taken. I mean, I'm biased, but what is this stuff? And you say, what, really? Well, it turns out that you can see those blotches here, right? Each one of these blotches, and I'm using for the first time a really cool purple pointer. I didn't even know they existed. I'm so impressed. Anyway, so it goes well with the black background. So you have these galaxies. What are these things? So each one of these blobs here is a conglomerate of hundreds of billions of stars. Okay, so when we look up at the sky at night, right, you're seeing in a very bright, I think tonight it may be a beautiful night to go look up, you're seeing, with luck, 1,000 stars. These are all our neighbors, okay? Each one of these guys is a galaxy. But the point is that, look how many are there, right? And you say, oh, so those little black dots here, what are these? I mean, these little faint guys, are these just stars? No, they're galaxies too. They're just far, much farther than the other ones. This picture goes billions of light years into the universe, okay? Which means that when you look at this little point of light over here, okay, you're receiving light that has traveled for billions of years to get to the telescope. What a fate, right? I mean, the light survives for billions of years and then hits the eye of the astronomer. It's kind of, and that's the end of it. But the point is that you say, okay, we're really small, right? I mean, this is a real small vision of I mean, we're just one little planet and one little star and one little, of course, the Milky Way is not here in this picture. I hope we all know why not, okay? But in any sense, just to give you an idea, the distances between these galaxies is of millions of light years. And so that's kind of a nice poetic touch, because that tells you that every time you look at the night sky, you're looking at the past. Because all the light that comes, it's coming from a long time ago. Even the sun. When you look at the sun, don't look for very long, please, but when you look at the sun, it's 8 minutes old, the light that gets there, because it takes 8 minutes for the light to travel from the sun to us. So if the sun exploded right now, you would find out in 8 minutes. And it would be the last thing you would ever know, right? Because it'll be the end of the whole. But you would find out that. And so that tells you that looking at the sky is sort of like a time machine to the past, you know? And you're learning more and more about our origins. That shows you how cosmology, you know, the study of the universe as a whole, is really connecting with our past, with our history, right? But what about us in this big scheme of things, right? Well, let's get a little local. So this is another amazing picture. You know, it looks like a lot of a blurred kind of thing, but this is like stars being born. And this was taken by the Hubble Space Telescope some time ago. So stars have nurseries, just like we have nurseries, you know, places where, no, the nurseries, our nurseries, the babies are not born there, but in the star nurseries, they're born there. So they are basically huge blobs of gas, right, that get together because of its own gravity, and they start shining, right? So that's how stars are born, and that's how the sun was born about 4.5 billion years ago. And with the sun, most of the matter of one of these big gas clouds that became the sun, the leftover stuff is the planets, right? So again, they say, okay, so now we're even the leftover stuff that didn't become the sun. I mean, great, right? And then, yes, and look at that. This is a picture that looks like completely irrelevant, right? But it's another amazing picture. This is a picture of the Earth. That's the Earth, seen from Saturn by the Voyager 1 satellite. Okay, so in the 70s, the satellite was sent off, and is the first human-built probe to get out of our solar system. It just happened some time ago, actually. And it turns out that it took, when it was going around Saturn, it took a picture of Earth. So here's Earth, right? This little pale blue dot, as Carl Sagan would say, right? And here's another picture of Earth. This one taken by the astronauts from Apollo 15 when they are orbiting the moon. This is the Earthrise. So we see the moon rise, right, or the sun rise. They were seeing the Earth rise, right? So this is our planet. And it turns out that nowadays, because of the advances of astronomy, we're able to find planets in different places, right? So stuff that people have dreamt of even thousands of years ago, like, can there be other planets out there? Now we know, yes, there can be other planets out there. Not just there can be, but there are lots of them. In fact, when you look at stars around the Milky Way, because we can't look at stars farther out, they're too far away, we find that most of them have planets, okay? So you say, okay, again, the Copernican stuff, right? So you have all these planets, and the Earth is just a planet. What's the point? Well, the point is that the Earth is not just a planet. The Earth is the planet, okay? It is a very, very, very special place. Just take a look around the solar system, our neighbors, right? So Venus, the beautiful star, right? Well, Venus is that bright. Do you know why Venus is that bright? Because its atmosphere is so dense that it reflects very well the solar light, right? Because planets, they always reflect the sunlight. Now, why is the atmosphere of Venus so dense? Because it's damn hot there. At the surface of Venus, the temperature is about 800 degrees. It's so hot that the rocks glow during the day and during the night, okay? And what is the atmosphere? It's mostly made of sulfur compounds. In fact, it rains sulfuric acid in Venus, and it smells of rotten eggs. So Venus is hell. I mean, think about it, right? It smells of sulfur, it has rocks that glow red, and it's just hell. And yet, the poets, you know, it's the gorgeous, beautiful light there. It is if you don't get close, right? So stay away. So there's obviously no light, no life there, right? Then you go to Mars, right? And Mars is this fascinating planet. It's kind of a little bit like the Earth, right, in terms of size. It also has a day which is about 24 hours. And problem is, Mars really is a frigid desert, right? It is incredibly cold there, and the atmosphere is only 12% density, the density of our atmosphere. So it's very, very kind of, it's very hard to breathe, even if you could breathe CO2, because it's all CO2, there's no oxygen over there. So just think that they sent a probe there that landed on a parachute, right? Now, isn't that amazing that you can actually have a parachute that works on an atmosphere that is only 12% the density of this one? To me, that's the magic of technology, right? That you can actually build these machines that can go to these worlds and do these amazing things, and we can watch from our television or computer screens, right? It's just, and it's all remote control, right? So when you're a kid, you're playing with like remote control cars or dolls that move around and they hit the leg of the table. You can hardly operate them. Imagine operating a robot that is going to another world, put a parachute through the atmosphere, land it because it has a Volkswagen Beetle-sized thing in there, which is a rover that is moving around with solar panels, and it works. Now, that to me is just mind-boggling, spectacular. I bet Neil deGrasse Tyson would agree, right? So what we're finding is that other planets, each planet is a different story. Each planet had a different history, a different evolution, and it turns out that the Earth is incredibly special. Right? The Earth is special because of its location with respect to the sun, because it has liquid water, because it has a heavy moon. It turns out that the Earth is tilted by 23 degrees, 23.5 degrees, and it's spinning like a top, like this, right? That's the 24-hour day cycle. Now, if the moon were not very heavy, or if you had more than one moon, the stability of this axis would not be very long-lived, which means that it would be doing wobbling stuff like this, which means we wouldn't have 4 seasons, which means the temperature in this planet would not be very stable, which means complex life would be impossible. So when you start to look at the history of the Earth and the history of life on Earth and all the hurdles that had to be overcome for life to exist and to exist in this complex form called humanity, you start to realize that we actually do matter, right? And we matter because life certainly must exist elsewhere. It would be really, really weird if the Earth, out of these just in our galaxy, there are trillions of other planets and moons, right? So to have life just here would be kind of strange, right? So most probably there is life in other worlds. However, that life will also most probably be very simple, sort of unicellular, like bacteria-like, which was the case in here for 3 billion of the 3.5 billion years that life existed here on Earth, okay? It's always been like amoeba-like stuff, right? I mean, so complex multicellular life is very recent in our history. Intelligent life, if it exists out there, will be even rarer for many, many, many reasons, right? And we know that, first of all, because we haven't heard from them, and there's all sorts of interesting arguments about why we haven't heard from them, which we can talk about later. But the point is that even if there is intelligent life somewhere else in the galaxy, we are, for all practices and purposes, alone, right? Just to give you an idea, if we used our fastest rocket ship right now to go to the nearest star, okay, which is Alpha Centauri, which is at about 4.5 light years away, 4.5 light years away. So it takes 4 years for light to come here, right, from that star. If we use our fastest rocket ship to get there, do you know how long it would take us? 120,000 years, right? So interstellar travel is really difficult, which basically means we are, in practice, alone, right? And we are alone, and life is rare. So what do we learn from modern science is not that we are irrelevant because the universe is so big, there are so many planets. What we are learning, at least that's my point of view, the point of view that I put forward, is that we matter because we are rare. We are these sort of molecular machines capable of self-reflection, of thinking about our origins, of building machines that can land on Mars, of creating treatises on philosophy and painting the Mona Lisa, right? So we matter because we're truly special in the big scheme of things, which for the next generation, for you guys coming over, means that we have a new moral imperative, which is to be the guardians of life and the guardians of this planet, especially now that we know that we can protect it and must protect it. So there, you have life becoming, science becoming existential in a sense, because it tells you things about the importance of humanity and the importance of life in the universe as a whole. So this is a quick sample of what we are about here. If you want to know a little more, I do have some books. That one just came out, and the Wall Street Journal thought it was really good, so it must be, I don't know. So that's it, folks. If you have any questions, please, I'll be happy to answer them. Thank you.